So for 8.3, we're going to now be combining the two things we just talked about in the last two sections. We're going to do composition of functions, and we're going to do inverses, and how are they related. So today is the properties of inverse functions. The question is, how can you tell whether two functions are inverses of each other? By using composition. And so we'll eventually get to how these two things are related. So we have some new notation to talk about inverses. It's very, very important that you understand the meaning of this for when we'll use this. If you have a function called f of x, then the inverse of this function is generally denoted this way, which is kind of weird, and it's read at the way you would not think it would be read. You have this f with a -1, which is like in the exponent area, and then of x next to it. But you do not read this like that. This does not mean f of x to the -1 power. But what it does mean, and I should probably write this in here, this just means, if you're reading this, f inverse of x is what this is. So you would say f inverse of x. So don't freak out when we use this notation, because it's just the same thing as just saying the inverse of x. We never had any notation up until now, but now we're going to be starting to use it. So let's go through an example. We're going to start with an original function equation, f of x equals 3x plus 11. We're going to find the inverse of this. So instead of going crazy and thinking about f of x and not knowing what to do with this, like we did before, we want this side to be y instead. So we're going to replace the f of x with just y. So what if we just put this in here and just say, okay, well, we're going to change this to the y equals 3x plus 11, just because we're used to seeing it like this. And then we'll do what we did when we talked about inverses the day before. So we're going to use the inverse relation theorem and switch the x and y in the equation for f. So we're going to switch the x and y, which gives us x equals 3y plus 11. So now this is kind of the same steps we did the day before, where we now switch the x and y and solve for y. So how do we solve for y? We got two steps. We have to subtract 11 on both sides. So you get x minus 11 equals 3y. This goes away. And then you divide both sides by 3. And you can just leave it like this. Nothing simplifies here. So you have y equals x minus 11 over 3. The only difference is we're not going to keep this as a y. So we could write this one more time like this. Y equals x minus 11 over 3. But we're not going to keep this as y. Our last step is we're going to change this, and we're going to substitute our new notation in for y, because this describes the inverse. So we'll change y out into f inverse of x equals x minus 11 over 3. So we're just changing the y out to that. So now we can see the relationship. Okay, this is the original equation, f of x, and this is the inverse equation, f inverse of x. So you can see the relationship between the two. Whereas before we just kept using y's and they didn't really mean anything. I had to write like the word inverse. Now we can just see it by looking at the notation. So we're going to do that again 2 more times. Find the inverse of each of the following equations here. So we're going to find f inverse and we're going to find g inverse. So first we're going to do our steps. We're going to change it to y equals 12x minus 4. Switch the x and y around. X equals 12y minus 4. Solve for y. Add 4. We get x plus 4 equals 12y. Divide by 12. So we get y equals x plus 4 over 12. And we can simplify that then. But don't forget, we're going to change this into the other form. Change the y into the inverse. So this is f inverse of x. Do the same thing over in this one. We're going to take g of x, change it to y. It's just a placeholder, so we're more used to what's going on here. Whoops. So it's be 12. And then we're going to switch the x and y. So don't forget to do that. X equals 1/3 plus y over 12. Now we have to get y by itself. So I'm going to move the 1/3 over by subtracting 1/3. That goes away. So we have x minus 1/3 equals y over 12. To get rid of the 12, we multiply both sides by 12. Don't forget to put this in parentheses. So these go away. And now I don't have to use y anymore. I'm going to change this to g inverse of x, put it on the left-hand side. And I'm going to simplify this over here. 12 times x is just 12x. 12 times negative 1/3. Well, think of it as 12 over 1. This would be 12 times 1, which is 12. The bottom would be 1 times 3, which is 3. It's 12 over 3, which is 4. So that's our inverse. And on this one here, I could go a little further. Let me actually divide these both by 12. So this would be, let me write it one more time here. We have f inverse of x equals x over 12 plus 4 over 12, which is 1/3. Now, hopefully you notice something about these two answers. What do you notice about the answers in the original problems for both of these? This inverse that we got with f of x is actually the original problem that we started with g of x. And over here, when we did the inverse of g of x, we actually got back the answer that we started with over here. So what do we notice about the answers for these two? We can say what? These two problems are actually inverses of each other. Like these two are the inverses of each other. So we can say f of x and g of x are inverses. Okay, so let's also go back and practice some composition of functions. So we're going to get two functions, and then we'll relate this to the inverses. We'll take two functions, 1/2 x plus 8 and 2x minus 16, and then we're going to simplify f of g of x and g of f of x. So like we did a couple days ago. So we do f of, what's g of x? Find it. It's this, 2x minus 16. Plug it in there. And then you take 2x minus 16, plug it into the f function. So it's going to go right there where that x is. So pretend you're taking that x out, or plug in 2x minus 16. So we have 1/2 times, not x, but this whole thing. So again, in parentheses, 2x minus 16. And don't forget the plus 8 on the end. Okay. So I'm actually going to solve this one and go a little further. Now that we know how to hopefully get through these two steps of composition, I'm going to solve this out by distributing the 1/2. So if you're multiplying by 1/2, just put them over 1. Might be easier for you to understand. 1/2 times 2, the 2's would cancel out, you get x. 1/2 of 16 is going to be 8. So you have x minus 8, and then we don't forget to bring down the plus 8. So our answer is, oh, look what happens here. These cross out. You just get x. So f of g of x is x. Interesting. Let's go the other direction. What if we do g of f of x? We would do g of, what's f of x? That is over here. And let's just probably get rid of some of this here. F of x is this whole thing, so that goes into the g of x function here. So we have 1/2 x plus 8. And then we go and find the g function and plug in this whole thing where we see x. So it's going to be right there. You take this out, and we put in 1/2 x plus 8 there. Okay, so we're going to have 2 times 1/2 x plus 8, and then minus 16. And again, we're going to simplify this one and see what we get. So we're going to multiply 2 times everything. So 2 times 1/2, well, we saw that before a little bit. 2 times a half is just 1x, or you just put x, doesn't matter. 2 times 8 is 16, and then we bring down our minus 16, and look what happens again. These last two numbers here, they cross out. They're both the same, positive 16 and negative 16, so we just get x. So we got both answers of x. This means something. If you ever do f of g of x and then flip it around and do g of f of x, do the composition of the functions both ways, and you get x both times, this means, just like in the last problem we did it, f of x and g of x are inverses. So it's kind of odd, but like if you look at these two problems, it may not be that noticeable, but these two are inverses of each other. And that only happens if you do f of g of x, g of f of x, and they both give you x. We don't want to equal anything else but x. If you got x plus 4 in one of these, it does not work. It has to be just x for both of them. Nothing else around it. So that is the inverse functions theorem, which is to say, if you have two functions, f and g, we can call them inverses only if we meet these two requirements. For all x in the domain of f, if we do g of f of x, we get x. But and is a pretty big and, because both of these have to hold true. And for all x in the domain of g, f of g of x equals x. If both of these things just equal x, then we know that they're inverses of each other. Okay, we're going to do 2 more examples and we'll be done. 3 more examples and then we're done. If f of x is 3x plus 6 and g of x is negative 6 plus 1/3 x, are f and g inverses of each other? Well, if it's asking if they're inverse of each other, the only way to really find that out in practicing our new thing is to do both of these. Now, it may be possible that you do one of them and you don't get x, and you can immediately say, hey, it's not inverse. So we could try that. So we'll do f of g of x. It doesn't matter which one you do first. So f of g of x would be f of g of x is right up there, negative 6 plus 1/3 x. Plug this into the f function right there. So we're going to get 3 times negative 6 plus 1/3 x plus 6. Okay, so we're going to distribute the 3. So we have negative 18 plus 3 times a third is just x, or 1x, plus 6. We can combine these two in the front and the last here. We get 1x minus negative 18 plus 6 would be minus 12. And that's your answer. Problem is, it is not x, so these are not inverses. So f and g are not inverses. We could just check and see the other way real quick. Let me just plug that in there. See what it looks like. It would be this with f, 3x plus 6, and that would go into the g function. Just seeing if it gave us a different answer. Distribute that, so negative 6 plus 1x. Looks like we're going to get 1x minus 4. So they're definitely not inverses. They'd have to both come out to be just x. So these are definitely not inverses of each other. But if you just get, you don't have to do both of these. Just the first one's fine. If you do this and you don't get x, either you did something wrong, or you actually figure it out and can say they're not inverses. All right, let's just do a little bit more of a complicated one. Now we're just going to practice find the inverse. So whenever you read this, don't get freaked out, right? You have this big equation here. It says find h inverse of x. That's what this is saying. So we'll do what we did before. Change this to y. Copy the rest down. And while I'm at it, I'm just going to switch the x and y without rewriting it again. So let's change this to x and y here. x and y. Now we'll solve for x, or solve for y. Since there's this big division sign here across everything, I'm going to multiply by 3. And that will cancel those out. So you get 3x equals 8y minus 2 plus 5. What else can you do here? Well, you could distribute the 8 if you wanted to. You don't have to do that, but you could. We probably will then. And then we can eventually put a number over there. So we can distribute the 8. That's fine. If you want to do that, do it that way. So we have 8y minus 16 plus 5 equals 3x. We can put those two numbers together. So we get 8y minus, what's minus 16 plus 5? Minus 11. And then we're almost there, almost getting y by itself. So we'd add 11 to both sides. 3x plus 11 equals 8y divided by 8. Alrighty, so we get y equals 3x plus 11 over 8. And of course, we don't want to have y there. I'm just going to replace that with the inverse. So I'm going to use that, h inverse of x. So this is the inverse of the original h of x. All right, last example. Power function theorem. So in general, if you have f of x equals x to the n, and g of x is x to the 1 over n, the domains of f and g are the set of non-negative real numbers. So you got to have positive ones only. Then you can use this and say, okay, then f and g are inverses of each other, inverse functions. So, for example, what is the inverse function of f of x equals g x to the 4th? We're going to graph both f and f inverse. So this only works, the 1 over n thing that we've done before, if you use positive numbers, and you'll see that in this case specifically. So what is the inverse function? So we'll change this to y equals x to the 4th. We'll find what f inverse is, so we'll say, switch these two. X equals y to the 4th. Get rid of this 4th power. I'm going to use this property up here. We're going to flip this fraction on both sides, so make it over 1. Flip it, make it 1/4. Do it over here. 1/4. These go away. So you get y equals x to the 1/4. Oh man, it's ugly. There we go. I'm going to replace it with my inverse answer up here. So I'm going to write this as f inverse of x equals x to the 1/4. And then I'm going to graph both of these so we can see what they look like. I don't think we've done these where we solved it and got the different powers here. So let's go ahead and open up Desmos. Okay. And graph that. So we have x to the 4th, which you should know what it already looks like. Is your happy face parabola. It's a little skinnier though. And then y equals x to the 1/4. Whoops, 1/4. Here we go. That's the other half of it. And we'll also throw in there the y equals x to see it go through the middle. Uh-oh. Delete that. Okay. A little better now. So you can see that we only get half of it because it only works for the positive values. We don't get the other half. We'd have to use the negative version of it. So this only works with all positives, non-negatives. And so we'll make a sketch of that real quick. So we have it going like this. And then the other half of it, so that was the original. Then we'll do this one, which looks like this. All right, so it only works with positive numbers. To get the other half, we'd have to use the negative version of this. So we don't get everything when we solve these for the powers. The rest of it you should be able to finish up. Use composition here to see if they're inverses. Okay. That one might be confusing. But let me try that one. Find a role for H or R inverse. Okay, and that's it. And that'll be all for 8.3.